Hello everyone, this is an introductory video for experiment number 5. So experiment number 5 builds on the skills that you learned in the previous experiments, including things like building a circuit on a breadboard, simulation, etc. But I wanted to point out a couple things that are new this time so that you know how the experiment is going to be run. So the couple things. First take a look at these two pieces of equipment. Again, I sent an email about this, and if you look at the documents that are already on Blackboard, I think you'll get an idea about the new piece of equipment, including the oscilloscope. So we're looking at the oscilloscope that we have in the lab. The oscilloscope itself is basically a voltmeter. It just measures voltage, just like the multimeter voltage mode. The difference here is that we can actually display the waveform and see the actual waveform visually. So that's what you're seeing. Excuse me. The screen over here is where you view the waveform, and all these buttons allow you to basically change the way the graph looks. So this is basically like a graph paper, and you can make, if you look closely, you'll see these little squares. It's like a graph paper. You can change how big or small those squares are. So on the horizontal scale, you will see time. So usually you will pick the time on the horizontal mode right here. By flipping this knob here, you can make those things bigger or smaller. And then we can measure two different waveforms, and these are called channel 1 and channel 2. And they have individual buttons to control the vertical spacing. So that's basically what it is. And nowadays scopes or oscilloscopes are very, very user-friendly, and it's a push-button process, and it's very similar to using a computer. Okay, so I think you will enjoy using these, and these type of instruments, the oscilloscopes. And as you can see, with the oscilloscope, channel 1 and channel 2, they both have two inputs, a plus and a minus, which is a red is the plus and black is the minus. So this is where you will make your connections from the actual breadboard. So if you want to measure a waveform from the breadboard, you'll make connections from the breadboard to the oscilloscope. Now the other thing about the experiment that's new is, instead of using a constant voltage source, we're actually going to use what's called a function generator or a waveform generator, and that looks like this. This is what's going to be on the bench. So you can basically set up different kind of waveforms, and you can see down here, these buttons allow you to set up a sine wave, a square wave, a ramp, a pulse, and different arbitrary waveforms. And you can actually see on the screen what you're applying. First you can see, for example, what the amplitude is, basically the magnitude of the sine wave, what the frequency is, how many cycles do you see per second. That's what hertz is. So like 1 kilohertz is 1,000 cycles per second, or 1 millisecond per cycle, right? 1 millisecond is the period, which is the inverse of the frequency. So it's pretty easy to set these up, and you just push the button. The knob basically allows you to change the frequency. With a little bit of trial and error, I think you can get this to work pretty easily. And the output is taken from this right terminal. So the first part of the experiment, what you will do is actually, you will take the output of this function generator. You'll be asked to set up a sine wave, 5 volt 1 kilohertz sine wave. So to make sure that it is actually what you want it to be, you will take the output of this function generator or waveform generator, and you will hook it up to channel 1 over here, for example. So you will hook the waveform generator directly to the scope and see the actual waveform here. Just double check before applying that waveform from here directly to the breadboard. So that's one part of the experiment, and as you look at the write-up, you will see that. So anyway, these are the two pieces of equipment that you will use, and you will be asked to set up a very simple circuit and analyze it. There's actually 3 different circuits that you will analyze. So to that end, let's take a look at those circuits on the simulation, because on the simulation this time, we'll be actually using a different mode of the simulator. So far we've used constant inputs, using the power supply, but now we're going to apply a sine wave. So with the sine wave, we will run what's called a transient analysis in the simulator. Transient analysis, also called time analysis. So let's just go to LTspice and launch it and see what happens. So I'm going to send you the first, we're going to use 3 different circuits. I'm actually going to upload 2 of those circuits so you can use those directly. There's nothing to do. Third circuit, you will modify 1 component value. Very, very easy, very, very straightforward. And in the write-up for the experiment, I ask you to simply download the 2 files that I give you, and I ask you to take those files, and place them in the EC115 folder on the desktop, and go to the desktop, double click on it, etc. There's different ways of running it, right? There's different. So one thing you can do is you can double click LTspice and go to the directory where your files are. In this case, it's in my EC115 directory. Experiment 5, circuit 1, for example. You choose it, open it, and here it is. This is actually the circuit. Okay. Another way you can do it, again, I'm just repeating this to make sure you understand how to do it, is let's say it's already in your EC115 folder, right? If it's already in your EC115 folder, so let me go to my folder. It happens to be right here. And I'll go to experiment 5, circuit 1, which is right here. You can also simply double click that file. It should automatically launch LTspice. So there's 2 ways of doing it. It's up to you. All right. Here's the circuit. Here's the first circuit. So in the first part of the experiment, you ask to simply go here, and basically it's ready to go. You just click on the running man. Okay. Run the simulation, and when you run the simulation, a blank waveform template comes up. And now we're going to do something different. So to display the waveforms, the node voltages corresponding to this in and out terminals, which have already been shown on the write-up of the experiment, all you do is you just take your cursor and you go on that node. It turns into this little red probe. Left click and you get the waveform. Okay? And then if you move the cursor to out, again, it turns into a probe. Left click, and there are your waveforms. So you have V in and V out. Okay? So if you maximize it, you'll be able to see it very carefully. I ask you to just sketch this, just sketch this out. There's only 3 cycles, right? 3 cycles of this waveform. Sketch both V in and V out, and make sure you mark which one is which. And put some divisions up there, put the 0 line maybe, put the 5 line, and put the 3, 4, 5. Just sketch it. If you sketch it approximately correct, it's fine. Doesn't have to be super perfect, but make sure you get many of the features on the the vertical and the horizontal to get a feel about how this waveform really looks like. So this is basically the first circuit, and this is what you will do for the simulation. And then for the experimental setup, I ask you to go basically set up the circuit, set up the 2 resistors. First, you have to get the resistors from your kit, right? The 10K and the 22K. I explain which colors those are. You could double check, okay? And you can also measure with the multimeter to double check those values are correct, okay? And then you're going to set up this circuit, okay? You're going to set up this circuit. And then, of course, this V in, okay, this V in, that's going to come from the function generator. So I ask you to first set it up, measure it with the oscilloscope, then connect it to your circuit, okay? By the way, over here, this is LTspice's way of notating a 5 volt 1 kilohertz sine wave. Okay, so it's 5 volts minus 5 volt is the amplitudes. 1 kilohertz is the 1K or 1000 hertz is the frequency. And this thing in the front is what's called the offset. So you can actually move the sine wave up and down by a constant factor. In this case, we are not. That's why this is 0, in case you're wondering what that 0 is. So this is a circuit. Go build it. And there are steps for you to set up the circuit first, set up V in first in your by just hooking up directly to the scope, making sure it is what it is, and then you connect it to your breadboard. And once you have it in your breadboard, then you will measure V in and V out. Okay, you will measure V in and V out by hooking these 2 points to the oscilloscope. Okay, so instead of just measuring with like a multimeter We're not going to look at the waveforms of these signals, V in and V out. So you will see that V in will go to channel 1 and V out will go to channel 2. I'll just leave it at that because I want you to experience some of that by following the procedure. Okay. Anyway, this is the first circuit. It'll be sent to you. You can just simulate it to start the experiment, and now you know what to expect. And then you'll make the waveform measurements with the scope, and we'll compare the simulation waveforms, which are shown here. We're going to compare this to the actual waveforms measured from the oscilloscope. Okay. So let's take a look at another circuit that I will send you. It's the experiment 5 circuit 2, which is sitting right here. Okay, now this one has a capacitor, and then you'll go get the capacitor from your kit. Okay, this is also from your kit. Again, 10K and 22K are in your kit. So it's a 0.1 microfarad. It's a small orange device that's with the capacitors in one of the bags. You will just place it across a 22K. Everything else will be the same, basically, in this circuit. You rerun the simulation. And you'll get different waveforms. So let me just remove the circuit that we had before, so it's clean. Okay, so this is the circuit now. Again, you'll measure V in and V out, and here they are. Okay, this is what we expect, and you see that the waveform is kind of moving down a little bit. It's kind of settling out, but this is what it kind of looks like. Okay, your scope measurement might not be exactly like this, of course, because it takes a while for the circuit to kind of steady out. And so you see some initial behavior, but basically you're seeing this behavior after a while. This is what the output is. Okay, so put this in there, sketch this, and now go build this. Okay, and building this is going to be very simple because you basically have everything to the left built, including the setup for the function generator, and so on and so forth. You have everything set up here. The only thing to do is just add C1 across your device, across the R2 device, and you're pretty much set. So that's ready to go. Okay, so once we've done this, the last thing is going to be experiment 5 circuit 3. Okay, so what I ask you to is, I just ask for you to change this resistor to a 1K. So what I'm going to ask you to do is change this to a 1K. The way you do it is you take your mouse button. Okay, you have to take your mouse button. You take your mouse cursor. You go on the 10K. Okay, turns to a different symbol. Okay, turns to a different symbol. Right click and change this to a 1K. Okay. Then what I ask you to do is I ask you to save this as a different file. So you're going to go File, Save As, and call it Experiment 5 Circuit 3, for example. And save it in the same directory where you're saving everything else. So now it's saved. It's a new circuit. Okay. Resimulate. Okay. And when you resimulate, what you'll see is that you don't have to reprobe the values. These will update. So let me show you what happens there. So if you go to Window and Tile, vertically, for example, you can see both the circuit and the waveform at the same time. But I have not run this yet. Okay, I have not run this yet. If you run it, okay, you will see everything updates, and now this is my new waveform, and I can maximize this. Okay, go ahead and sketch this, and also, this is from the circuit. Go build this. Building this is going to be very easy. All you're going to do is take R1, which was 10K, change it to a 1K. Again, there are 1K resistors in your kit. Change it to a 1K and look at the results again. So very, very straightforward. Once you build the same circuit, okay, once you build the first circuit, the subsequent circuits are very, very easy. One involves adding a C1, and one involves changing this 10K that was originally 10K to a 1K. Okay, so I hope this will be an interesting experiment. You'll get both. Again, you'll see the simulation results, and at the same time, you're going to be comparing it to waveforms from the oscilloscope. You'll be using the function generator. So I hope you have a good time with it, and I hope that the waveforms match and they're validated, and I hope you have a good time. So thanks very much for watching, and I hope to see you in class soon. Thank you.